Set of slides, we've finished with matter and a little bit about energy and laws of conservation. As I said, the whole semester is going to be about matter. So let me go ahead and start going through these. And one of the things you can get out of this set of slides is kind of how we think like scientists, and I'll explain that as we go. This may or may not be broken up into two videos. All right, so as I said, matter, right? There's matter and empty space. So the way scientists look at matter, if you think about theories and hypotheses, a theory, another way of saying it is it's a model. And so this is kind of how we look at stuff. And you'll see how we can look at everyday occurrences, stuff that you're familiar with, and yet talk about it from a scientific perspective and explain why. So one of the ideas, we already talked about this, matter is anything that has mass and occupies space. Matter is composed of tiny particles. And those discrete particles are called atoms. And we'll spend much more time on this as we progress as well. All right. One way of looking at it is what's called kinetic molecular theory. This is traditionally used to discuss the gas laws. And so you'll see when you look at sections we're covering in the textbook, you'll see I kind of jumped to a different chapter. But in general, all matter is made of tiny particles. These particles are in constant motion. Okay, so it's kind of redundant here. Realize that to be moving, you only have to have one of the three types of motions. Let me explain what they are. There's vibrational motion, which is literally just shaking, vibrating, just what it sounds like. Rotational motion, which is spinning on an axis. And translational motion, which is when particles move past each other. So if you look at just the cursor moving from here to here, would be translational motion. The last part isn't terribly important until we deal with this. We'll deal with this later, but for sake of completion, particles move in straight lines until they collide. And when they collide, they bounce off. And also, temperature is related to particle speed. So if you increase the temperature, particles move faster. So what we're going to do is I'm going to use this to explain stuff you already knew, solids, liquids, and gases. All right, so let's think in terms of what is a solid, what is a liquid, what is a gas. So instead of thinking of examples, I want you to think in terms of how you would describe a solid, a liquid, or a gas. And hit pause for a second, see if you can think of that, and then I'll come back to it. So I'm going to just count to 5, and then I'll move to the next slide. All right, so if we look at it, we'll start actually on the right here. A solid, and hopefully you thought of this, is something that has a definite shape. So it has a fixed shape. So if a solid is a cube, no matter what container it is in, it's a cube. If it's diamond shaped, if it's round, it doesn't change its shape if you put it in a container of different shape. In addition, a solid has a constant volume. So if I put a solid that takes up 5 liters and I put it in a 300-liter container, the solid still only takes up 5 liters. And the reason for this is the particles are in a fixed position. They have vibrational motion only. They're very, very crowded. All right. In a liquid, now if you think about liquids, if you just think in these terms, and one other thing that's not really here is compressibility. Solids really can't be compressed. You can't really squish them very well. All right. For liquids, a liquid has a different shape. Right? It can change its shape. So if you put a liquid in a square container, it's square. If you put a liquid in a spherical container, it's spherical. If you put it in a cylindrical container, it's cylindrical. You can try this at home, right? Just pour a liquid from one shaped cup to another shaped cup, it changes shape. However, the volume is the same. So if I have 100 milliliters here, if I put it into a bigger container, it still only takes up 100 milliliters. It doesn't matter. Now the particles are closer together, are further apart. They're relatively free to move. They have all different types of motion. And to change shape, if you think about what the particles have to be able to do, to change the shape, the particles have got to be able to move past each other. So this particle here has to be able to move to here. Where in a solid, that can't happen because they're too close together. All right, so they're free to move. However, a good question, if you look at where the cursor is, a liquid, right, isn't up here. So what prevents this very last particle from going this way? The particle can't go this way because there's other particles in its way. But why does the last particle not go this way? And the answer is that the particles are attracted to each other. They stick together. And the next slides will describe that. All right. Also, liquids, though they're not very compressible, they have a little bit of compressibility. All right, now gases, if you think about the shape and the volume, a gas, the shape of a gas is the shape of the container. So a gas, just like a liquid, they have indefinite shape. However, unlike a liquid, a gas fills the container no matter what size container it is. So if I have gas in a 100 milliliters of gas and I put it in a 3-liter container, it will fill up, it'll be in 3 liters. If I open it up, it fills the room. All right? And can you squish a gas? Gases are very compressible. So why is that? Particles are free to move, and unlike in a liquid, right, this particle can't go this way because they're sticking. Gas particles do not interact. I think the next slides go into more detail about each one. Yes, so this will be a review. Solids have a definite shape, a definite volume. They're essentially not compressible. Particles are very tightly packed together. They have vibrational motion only. They're held together by very strong forces of attraction. So they stick together, they can't move past each other, and they hold onto each other very tightly. That's why a solid has a definite shape and a definite volume. Liquids have no definite shape, as we said. I'm doing this more quickly because they have a definite volume, however. They're a little tiny bit compressible. You can squish them a little. The particles are free to move, but they are still held together by forces of attraction, which is why they have a definite volume. That's why this liquid particle is not up here. A gas has no definite shape and no definite volume. The reason for that is that gas, and they're very compressible. And that's because they're extremely far apart. They're so far apart that they basically do not interact with each other. The attractive forces are very weak. So basically each gas particle thinks it's by itself. In fact, when gas particles start to interact, that's when they turn into a liquid. All right? So what I want you to be able to do is describe solids, liquids, and gases not only in terms of their shape, volume, and compressibility, but why. Why does a gas have no definite volume, but a liquid does have a definite volume? And the answer is a gas, the particles don't interact, and a liquid, they do. How come a solid cannot change its shape, but a liquid can change its shape? That's because in a liquid, the particles can move past each other. So, and this is what I mean by what scientists do. Nature does what nature does. Scientists' job is we try to explain how it does what it does. Okay, some other ways of classifying matter are breaking it down into a couple of different groups. So matter can be broken down into two traditional groups. There's mixtures and pure substances. So, and you can see here, a mixture is when we have one or more things in the same container. A pure substance is one thing. Okay? And then mixtures can be heterogeneous or homogeneous. You might be familiar with the prefixes, hetero meaning different, homo meaning same. Okay? So in a mixture that is heterogeneous, that means you can kind of tell it's mixed. The properties are not evenly distributed. A homogeneous mixture, it's evenly mixed. And then pure substances come in elements and compounds. And the next slides will go through this as well. All right, so just like I said, okay, a pure substance, definite composition, it's one thing, has a unique set of properties. It can be an element or a compound. It can't be broken up into its parts by a physical change. A mixture is just a couple of things in the same container. And that means it's going to have, if there's 3 things in the container, there will be 3 different sets of properties. So each thing has its own properties. And it can be separated by physical changes. And in fact, what you do to separate a mixture is you take advantage of the differences in properties. So let's look at this. Okay? So let's just focus on mixtures first. We just said this. Mixtures can be homogeneous or heterogeneous. So a heterogeneous mixture, like this, the sand, you can see it's obviously a mixture, and depending on where you take your sample, you'll have more of the brown stuff or more of the black stuff, just depends, it's not evenly mixed, right? A solution or a homogeneous mixture is evenly mixed, so no matter where you take your sample, you'll have the same composition, the same sets of properties. So if I have, for example, if I have salt water, right, it's a mixture of salt and water, but if I take my sample from here, I'll have the same percent salt as if I take my sample from here or down here. Okay, that would be homogeneous. So homo means same. And again, in mixtures, you can separate them by taking advantage of the differences in the properties. So for example, just in your everyday life, if you've ever made pasta, you take pasta and water, right? And now you have a mixture of pasta and water. And how do you separate it? You pour it through a strainer. And what you're doing is you're taking advantage of the fact that water molecules are smaller than the holes, and pasta molecules, if you will, are bigger. And so you're separating them by size in that case. All right, let me see how many slides. So I'm going to decide how far I'm going to go. Go back to here. I'm going to stop here, and we'll pick up on pure substances in the next video. All right, so let's just do that. This is video 1.